There's a rocket that changed everything. For over a decade, it launched astronauts into space, carried billion-dollar satellites into orbit, and made history so many times that people almost stopped noticing. That rocket is Falcon 9. And now, the very company that built it is preparing to walk away from it. Not because it failed, but because something bigger is coming. To understand why this moment feels so significant, you have to understand what Falcon 9 actually accomplished. Since its first launch on June 4, 2010, Falcon 9 didn't just become a successful rocket, it redefined what a rocket could be. It became the most frequently flown orbital rocket in human history by a massive margin. In 2025 alone, SpaceX completed around 165 orbital launches. Every single one of them used a Falcon 9. That means nearly 85% of all U.S. orbital launches that year depended on a single rocket family. To put that in global perspective, China, one of the world's most active space powers, completed around 90 launches that same year. Russia managed about 17. Falcon 9 outflew them both, combined. And it wasn't just about raw numbers. Out of roughly 637 launch attempts, Falcon 9 succeeded on more than 630 of them, a reliability rate of nearly 99.5%. It carried NASA astronauts. It deployed national security payloads. It built the Starlink constellation satellite by satellite. With an estimated launch price of around $74 million, often cheaper than any competitor, Falcon 9 became the financial engine that powered SpaceX's rise. It's rare in aerospace, a rocket that is both revolutionary and proven. That's the question that makes people uncomfortable. Critics have a point. Falcon 9 works, it works remarkably well, and the replacement being proposed, a giant rocket called Starship, is still fighting through its development phase. It hasn't yet proven consistent orbital re-entry. Full reusability of its upper stage remains undemonstrated at scale. Many people in the industry argue the logic doesn't even make sense. You don't need something as big as Starship for most launches. Different mission sizes require different rockets. Most spacecraft are getting smaller, not larger. These are fair arguments. They reflect decades of aerospace wisdom. But SpaceX's supporters see something entirely different when they look at the future. The vision isn't about size, it's about cost. Right now, even with its reusable booster, Falcon 9 still loses its entire second stage on every single flight. That upper stage burns up in the atmosphere after delivering its payload. Each time that happens, roughly $10 million worth of hardware disappears forever. Starship is designed to change that completely. Both the booster and the upper stage would be caught and reused directly at the launch tower using giant mechanical arms nicknamed Mechazilla. No landing legs, no wasted mass, no discarded hardware. When that system works at full efficiency, the estimated cost per Starship launch drops to around $10 million, compared to $70 million for a Falcon 9 today. That's not an upgrade, that's a transformation. A few years ago, Starship was mostly famous for exploding during test flights. That era is over. The program has matured significantly. Starship has now demonstrated stage separation, orbital re-entry, controlled descent, payload door operations, and even in-space propellant transfer between internal tanks, a technology critical for future deep space missions. Now comes the chapter that matters most, Block 3. Unlike earlier prototypes designed simply to survive, Block 3 is considered the first truly operational class version of Starship. SpaceX's major goal for 2026 is flying it on a full orbital trajectory, validating long-duration coast operations, orbital insertion, and controlled re-entry under real mission conditions. More importantly, Block 3 is built around one central idea: rapid reusability, the ability to land, refuel, and launch again, quickly, cheaply, repeatedly. Because without that, nothing else works. Here's something most people miss about this transition. SpaceX isn't planning to hand Starship over to paying customers first and hope for the best. Instead, they're going to do something they've done before. They're going to use their own satellites to prove the rocket works. This is exactly how Falcon 9 matured. Year after year, constant Starlink launches pushed the rocket harder, faster, and more frequently than any outside customer ever could. Engineers refined every system through sheer repetition. Starship will follow the same path. And the timing is perfect because Starlink itself is evolving. The next generation of Starlink satellites V3 are expected to weigh around 2 tons each. Falcon 9 physically cannot carry them efficiently in large numbers. Starship, with its enormous payload capacity, becomes the only practical vehicle for deploying the future constellation. During test flights in 2025, SpaceX already began simulating exactly this. Flight 10 in August deployed 8 Starlink V3 mass simulators into orbit, validating deployment sequencing and orbital release procedures. Flight 11 in October repeated the process, further refining the architecture. These weren't real Starlink missions yet, but they represented something significant the moment Starship began transforming from an experimental machine into a future launch platform. Operational Starlink missions aboard Starship are expected to begin ramping up from 2026 onward, potentially accelerating dramatically around 2027. If that ramp-up happens, the numbers become staggering. SpaceX's long-term target, according to the company's own leadership, is approximately 400 Starship launches within 4 years. To understand how aggressive that is, Falcon 9 took roughly 14 years to accumulate a similar number of flights. Meanwhile, on the ground, the infrastructure tells the same story. At Kennedy Space Center in Florida, Launch Complex 39A is being gradually transformed for Starship operations. Falcon 9 launches there are quietly being reduced to make room. Down in Texas, the launch site at Boca Chica continues expanding. One of SpaceX's drone ship barges has reportedly been retired from Falcon booster recovery and repurposed to transport Starship components. These aren't the decisions of a company still testing Starship. These are the decisions of a company preparing to operate it. The internal timeline points toward around 2030 as the real turning point, the moment when Falcon 9 and Dragon could begin their final retirement. A timeline that, not coincidentally, aligns closely with the planned retirement of the International Space Station itself. Here's what makes this moment feel different from ordinary technological progress. Falcon 9 didn't just succeed. It earned something rare, genuine public trust built through hundreds of missions and years of reliability. Walking away from that trust, placing it instead in an unproven system, is a gamble of historic proportions. But SpaceX has always been a company that bets on futures that don't yet exist. They bet on reusable rockets when the industry said it was impossible. They bet on commercial spaceflight when governments own the sky. And now they're betting that the economics of space travel can be transformed so completely that everything built before Starship will eventually look like a stepping stone. Whether they're right or wrong, one thing is certain. The era of Falcon 9, one of the greatest machines humanity has ever built, is quietly, gradually drawing to a close. And whatever comes next will either justify that decision entirely or stand as the most expensive mistake in the history of spaceflight.